Good morning to all. I am Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. As the second part of this lecture series, second video is about the other types of funneling. The first one is stress relief funneling. As the name implies, it is mainly used to relieve the stress that occurs during the processing of any material. So this type of stress relieving funneling ranges from 550 to 700 degrees Celsius. So the stress relieving happens, or the other ways we can say it eliminates stress that are formed during welding or cold working or casting, quenching, machining process. The main important thing is the stress relieving is that uniform cooling. If the uniform cooling is not happening, then the stress is unevenly removed. So this uneven stress removal will also leads to the crack formation process. And the second type of funneling is that, or the third type of funneling is known as recrystallization funneling. So this recrystallization funneling, the first one I will say that this recrystallization funneling is used to replace the older or we can say distorted grains into distorted grains is replaced by the strain-free new grains. The second one is that during this recrystallization annealing process, there is no phase transformation going to happen, and this recrystallization annealing does not restricted to a certain temperature line, but it can be easily, but it can be found that this recrystallization temperature can be the 1/4 of the melting point of material. For example, if a melting point of material is 1000 degrees Celsius, then 400 degrees Celsius will be the recrystallization temperature for the certain material where recrystallization annealing can be done. So this recrystallization annealing helps to improve the ductility and the formability of a material. Meanwhile, there's as always we have some disadvantages that the strength and hardness of the material will decrease, and moreover we can say it reduces the dislocation density and it converts the elongated grains into equiaxial grains. So this recrystallization annealing will replace the distorted grains during the working of metal into strain-free new grains and without any phase transformation. So that is the more important one. So as I previously say, the third phase transformation is the most important point in recrystallization annealing. So this recrystallization temperature for a metal can be found that this recrystallization temperature is the 1/4 of the melting point, and you can easily say the strength and hardness of a material will decrease as in the progress of recrystallization takes place. Then the ductility and toughness of a material will gradually increase. The last type of funneling is that it is known as periodizing. As you can simply say, this periodizing is predominantly used. It is predominantly used to convert perlite and cementite matrices. So it converts lamellar perlite structures into globular perlite. That means lamellar means line format, globular means in a dot format. So lamellar plates into globular perlites, and cementite plates into spheroids. These spheroids can be seen like a bullseye. So you can improve the properties by you can improve the properties of a material. In another aspect, you can say the main objective of the periodizing is to soften the metal, increase the ductility and toughness, and also improves the machinability and formability, and it reduces the hardness, strength and wear resistance for a material. The main thing is that this periodizing cannot be used for low carbon steel. It is concentrated on medium carbon and high carbon steel, specifically on tool steels. Thank you.